Did you know the optimal launch angle for maximum distance is 45 degrees? But that is only true under perfect theoretical conditions, like in a physics textbook, where there is no air or wind. In the real world, air resistance, human biomechanics, spin, and release height all push that number lower. So the best angle depends on what you are launching and where. In basic physics, a projectile launched from ground level in a vacuum travels the farthest at exactly 45 degrees. That is the angle where the horizontal and vertical parts of motion work together neatly. At 30 degrees, the object may stay too low and land too soon. At 60 degrees, it climbs too high but doesn't move forward as much. At 45 degrees, those two effects balance pretty well. But once air gets involved, things change fast. Air resistance slows a projectile throughout its flight. A higher angle throw stays in the air longer, giving drag more time to slow it down. So lowering the angle slightly can help an object keep more forward speed and land farther away. For most real-world projectiles moving through air, the optimal angle for maximum distance drops below 45 degrees. How far below depends on the object shape, weight, speed, and surface texture. A dense cannonball barely notices air resistance compared to a lightweight soccer ball. Several factors influence how hard and far a human can throw an object. Stronger muscles generate more force, which helps create a faster throw. Proper forms such as a full rotational motion can improve efficiency. Heavier objects require more effort to throw well. A firm but controlled grip helps transfer energy smoothly. Wind and altitude can also affect distance. In other words, throwing is not just arm power, it is science with a little drama. Golf is one of the clearest examples of how launch angle optimization works in practice. Because launch monitors measure it preciously, the optimal driver launch angle for most golfers often falls around 10 to 17 degrees, far below what physics class would suggest. Because the golf ball generates lift through backspin. In the case of a javelin, the ideal throwing angle has been debated for years. However, research suggests that an angle between about 30 and 36 degrees relative to the ground is often better for maximum distance. Factors like the thrower's height, speed, wind condition, and javelin design can all influence this angle. Speed plays a dual role in javelin throwing. First, the speed gained during the run-up adds energy to the throw. Second, the speed of the arm during release has a huge impact on the javelin final velocity. So in javelin, speed is not just important, it is the whole point. For stones, the best angle for most people throwing from ground level is often around 30 to 40 degrees. But gravity and launch height matter a lot here too. Gravity is one of the main villains of projectile motion. It constantly pulls the stone downward at 9.8 meters per second square. More height in the throw can also mean more distance, especially if you launch from a hill, roof, or elevated platform. Paper airplanes are a different story because they rely on lift. If you throw them too high, they climb, lose speed, and nose dive straight into the ground like a tiny exhausted bird. For paper airplanes, you want to launch almost parallel to the ground with only a slight upward tilt around 0 to 10 degrees. There are also a few common misconceptions about throwing. Some people think heavier objects always travel farther, but that is not true. In a vacuum, mass does not affect range, and in real life, heavier objects may travel slightly farther only because drag affects them less. Another myth is that all projectiles follows a perfect parabola. Real-world factors like wind speed and uneven launch heights can distort the path. And while throwing harder usually helps, angles matters too. A powerful throw at a bad angle can travel less distance than a smarter throw at the right one. So yes, technique matters a lot. A trained athlete with good form can often throw farther than a strong person with bad technique. Power helps, but precision wins more often than people think. That is the real secret behind throwing far. So next time, do not just throw harder, throw smarter.